All right, M means midpoints, and this 3 here means N equals 3. So delta X would be B minus A over N. So each rectangle has width 2. So you really just need the number line. So 0, 2, 4, 6. So there's 1, 2, 3 rectangles. And so M sub 3, each rectangle is of width 2, and I'm going to be picking the middle point. So it'll be f of 1 plus width 2, f of 3 plus width 2, f of 5, and then you're putting in the function. So you're putting 1 into the x cubed function, so I get 2 plus 2 times 3 cubed, which is 27, plus 2 times 5 cubed, which is 125. So all told, that gives you 306. Okay, so this says it's being dropped from 400 meters. So that gives you S naught is 400, 400, but it's being dropped, but it's descending. So it's in a balloon that's going down. So your initial velocity is -10, and that's all we got. So we got acceleration of gravity, -9.8. The velocity will be -9.8 t minus 10, and then my position function will be -4.9 t squared minus 10t plus my 400. Okay, how fast the velocity at which it hits the ground. So first I have to set the position equal to 0. So using my quadratic formula, I get opposite of b plus or minus. So I get 100 minus 4 times -4.9 times 400, it's ugly, over 2a, -4.9. So using the positive time that I get the time of 8.06. So it wants how fast it hits the ground. This is the time it hits the ground. So I take that time and put it into the velocity function. So I end up getting around -90. Okay, L sub 5, so delta X is 11 minus 1 over 5, because N is equal to 5 here. So I get to 10 divided by 5, which is 2 again. So I'm starting at 1. And so 3, 5, 7, 9, and 11. So again, I really don't need the function, I just need the number line. So L sub 5 will be width of 2 times, using the left-hand endpoint, e to the -1, plus width of 2, e to the -3, plus width of 2, e to the -5, e to the -7, and e to the -9. So I should have 1, 2, 3, 4, 5 rectangles that I'm adding together. All right, so now I am looking at 1,200 square meters of material to make a box. So 1,200 is the surface area. So it's got a square base and 4 sides of area XH each. And so I can see that's constraint, and I want to find the largest volume. So volume is what I want to maximize. So that's x squared h. So again, I'm thinking that's the one I want to take the derivative of and set equal to 0. So I want to solve for h. And I would clean this up before I take the put it in the other equation to take the derivative. X squared over 4x. So I get 300 over x minus x over 4 is equal to h. So I'm substituting it into here. So let me bring it here. So volume is x squared, 300 over x minus x over 4. So I get 300x minus 1/4 x cubed. Now I'm ready to take the derivative. 300 minus 3/4 x squared, set that equal to 0. So 300 is 3/4 x squared. So 400 is equal to x squared. So 20 is equal to x. So how do I find the h? So I go back and put it back into 1,200 equal x squared plus 4xh. So I get 1,200 minus, or equals 400 plus 4 already h, and then I can solve for h, and I got h is equal to 10. Oh, this probably would have been a better place to put it in. All right, last one. So we're supposed to have a volume of 100 cubic meters, which is x squared h. So the cost is going to be $5 for each of the sides, so that's 4xh, plus the base is $10, so 10x squared. So I'm going to solve this for h, and I'm going to put that in, so 20x, and that'll be times 100 over x squared plus 10x squared. Again, I'm going to clean this up. So I get 2,000 over x plus 10x squared. Now I'm going to take the derivative. So you know that this is the same thing as saying 2,000 times x to the negative 1 plus 10x squared. So when taking the derivative, I get negative 2,000 x to the negative 2 plus 20x. Set that equal to 0. It can be useful to rewrite this in the denominator. And I'm going to move this to the other side. So they're both negative, so I'll make them both positive. And then let's multiply by x squared and divide by the 20. So cross multiplying x cubed, so I get 100 is x cubed, so I'll keep the cube root of both sides, so that's x. And then to find h, I'll come back over here, so h is equal to 100, and then it'll be over x to the 2/3 power.